The video is on the solutions of difference equation in Z transform. So before going to the specific function, let us have the system function. So suppose we are having an nth order linear time discrete time system which was specified by the difference equation, which is having summation of n that varies from k is equal to 0 to capital N, and with the coefficients of ak and with the output of y of n minus k, and for the inputs that were defined by the coefficients bk, and the input that is defined by x of n minus k, where the k variable varies from 0 to m in the input side and from 0 to n in the output side. So on taking the Z transform on the both the sides and applying the initial conditions as a 0 on both the cases, we are having, or we have obtained the transfer function as y of z divided by x of z. So y of z we are having on cross multiplying, we will be having this particular equation. If not the above equation, it was y of n minus k, so it is y of z rewritten as y of z with the coefficients of ak, from that k varies from 0 to n. So here on cross multiplying, y of z into a naught plus a1 plus z inverse plus a2 plus z power minus 2 plus an into z power minus n, same wise x of z multiplied by the b naught coefficients. So on rewriting for transfer functions y of z divided by x of z, we have obtained the b naught divided by a naught terms. So with this we are moving to the simplifications, and this is how we have obtained a transfer function or the system function of the difference equations. So next, the transfer function of a system, it is given by the ratio of the output of the system to the input of the system. We are assuming the initial conditions as 0. So let us dive into the problem. So find the impulse response and step response of the system, which is having the following system function y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2, which is equal to x of n. On taking the Z transform on the both the sides, we are having y for instead of y of n, if we apply the Z transform, it will be replaced by y of z. In the second term, we are having y of n minus 1, so that will be replaced by z power minus 1 y of z. In the third term, it is y of n minus 2, so that will be replaced by z power minus 2 plus z power minus 1 into y of n plus y of minus 2. Okay, which is equal to x of n replaced by x of z. So we are having the initial conditions as 0, so we are assuming y of minus 1 and y of minus 2 as 0 in the both the cases. So it will be generally it will be become instead of y of n minus 1, it is z power minus 1, y of n minus 2 is z power minus 2. So on taking the y of z as a common terms and bringing the x of z term as a denominator, it will give one transfer function which is equal to 1 divided by 1 minus 3 by 4 z inverse plus 1 by 2 z power minus 2. For finding the impulse response, let us assume the input of the system is an impulse response. Here the input, it was denoted by x of z. So the impulse response del of 1 when we take the z transform for del, it will give 1. So x of z is equal to 1. So solve the transfer function y of z divided by x of z is equal to 1. So we obtained the function as z square divided by z square minus 3z divided by 4 plus 1 by 8. And taking partial fractions for finding the coefficients, a is equal to 2 and for b is equal to minus 1, and solving that we obtained y of z is equal to something 2 into 2 is 2 divided by z minus 1 by 2, 1 minus of 1 divided by z minus 1 by 4. So cross multiplying the z, it will give the general form. It is z divided by z minus a is equal to a power n into z u of n. instead of a and the first term we are having 1 by 2 and the second term we are having 1 by 4. So z divided by z minus a is equal to a power n into u of n. It is a generic equation, so which is equal to on taking the inverse transform of y of z, it gives the multiplicative factor 2 into the coefficient, it is z divided by z minus 1 by 2, so 1 by 2 the whole power n into u of n minus 1 by 4 the whole power n into u of n. This is for impulse response. Next is for step response. For step response, it is x of n is equal to u of n. This is taking z transform of x of n, x of z is equal to z divided by z minus 1. So we are having x of z term in a denominator, cross multiply by the term, and we are having some equations like z square divided by z minus 1 into z minus 1 by 2 z minus 1 by 4. Then we apply the partial fractions for finding the roots of the equation. So hence we have found it as a is equal to 8 by 3, b is equal to minus 2, c is equal to 1 by 3. On applying all these coefficients values, your y of z is equal to 8 by 3 z into z minus 1 minus 2 into z divided by z minus 1 by 2 plus 1 by 3 into z divided by z minus 1 by 4. So again taking the inverse z transform, so y of z while taking that, so y of n is equal to 8 by 3 into z divided by z minus 1. Actually it is 1 power n into u of n, since z is in previous one we know that z divided by z minus a is equal to a power n into u of n. So we have, instead of a we have 1, so 1 power n into u of n minus 2 into the second term, instead of a it is 1 by 2, so here 2 into 1 by 2 whole power n u of n, again 1 by 3 into 1 by 4 whole power n into u of n. So this is how we have obtained the step response and the impulse response of the system. If they are asking for the response of the system or the transfer function of the system, it is sufficient that you have to found y is divided by x of z. Thank you.